My name is Lillian Lower, and I'm a master's student at NC State studying biological and agricultural engineering. I'm originally from Casper, Wyoming, and I received my Bachelor's of Science in Civil Engineering at Gonzaga University in Spokane, Washington. My master's project is focused on producing biogas from Lemnaceae or duckweed biomass via anaerobic digestion at thermophilic conditions. Biogas is largely composed of methane and carbon dioxide and can be used as a direct replacement for natural gas, which is a non-renewable energy source. Duckweed is a common aquatic plant and is one of the fastest growing plants in the world. Compared to corn, which is a common bioenergy feedstock, duckweed can produce 50 times more dry biomass in 1 hectare of land. Duckweed also doesn't pose a threat to food production because it doesn't require arable land, and it can even treat wastewater while it grows. We are feeding duckweed and swine wastewater to anaerobic digesters that contain microbial communities in the absence of air that will break up and process the duckweed and release biogas that can be collected and used for heat or electricity. We're specifically looking at anaerobic digestion performance at thermophilic conditions, or about 50 degrees Celsius, because this temperature enables a shorter hydraulic retention time and can process duckweed at an accelerated rate. To evaluate if duckweed is a viable feedstock for anaerobic digestion, I've been operating 3 continuous digesters that I've maintained for over a year with daily feeding and biogas monitoring. To see the full potential for methane production from the system, I've also conducted biomethane potential tests in smaller batch reactors. For both the continuous and batch processes, it is important to measure the composition of the biogas via gas chromatography. This tells me the concentration of methane and CO2 in the biogas as the experiment progresses. The purpose of this project is to verify if duckweed is a viable feedstock for thermophilic anaerobic digestion and if there is a way to optimize the production of methane. If this project is successful and able to be scaled up, it could one day be performed on farms as a way to reduce nutrient contents of swine wastewater lagoons while producing biofuel in the form of biogas. After completing my master's degree, I plan on continuing my academic career and working towards my PhD at NC State, with the final goal of becoming a professor and mentor in the fields of academia and scientific research.